Hello everybody and welcome to another enVision's Algebra 2 math video. We're looking at topic 4 lesson 3, example 3, multiplying rational expressions and then trying it. All right, so we're going to look at this expression 2xy over z and 3x squared divided by 4yz. So let's grab this. Take it over to my notebook, put it in there. All right. So just like if I had 2/3 times 3/5, we're going to first look for any factors that we can eliminate. So the 3's we could cancel out and we're left with 2/5. So it's really good to get everything in factored form. In our case, everything is a factor. Everything can multiply to each other. So what I'm looking at here is 2xy times 3x squared, multiplying straight across, z times 4yz. Well, 4 can be actually broken up a little bit further. 4 can be 2 times 2. And let's see, nothing else here. So let's start looking at values we can eliminate, values that we could cancel out. So that 2 and this 2 could get canceled out. This y and that y doesn't look like anything else. Okay, so now let's multiply going across. So I have a 3 here, multiplying coefficients first. Next is the variable x. We have 2 x's here. We have a 1x here. 2 plus 1 is 3. We have 1xz here and 1z there. So that's 1 plus 1 is 2. So my final product is 3x cubed divided by z squared, where y, and you're asking why is coming into play here. It's because it's in the original equation. So we do have to call out that y cannot equal 0 or z cannot equal 0 because it was part of our original equation. And so we cannot have that as part of our y domain. All right, so let's go back here. And we'll see their solution. And again, here's your y's and z's. Again, because we don't even have y here, but we did have it in the original equation, we do need to call it out. All right, let's go to part 2. I don't know where I was going there. What is the simplified form of this monstrosity? Let's grab him. I left some of those 2's out, but we could understand that those were 2's. Okay, first thing, I said that you need to figure out the factors that you could cancel out. So we need this to become factored form, which means this guy, this one, and then this one, and I think this one has a factor we could pull out of it. Need to get factors pulled out. All right, so I have 5x. 2 numbers that will multiply to give me -6, add to get me +1. Well, let's think of 6 are 2 and 3. And if I subtract them, I get 1. This is a +1, so the positive goes on the bigger factor. Then this one has an x I can pull out. Greatest common factor of an x. I already have an x in the front, so we're going to multiply that x to that x. So we get x squared there. And this one is x plus 1. So again, I just moved the greatest common factor that I pulled out here to the front, multiplied it to this x to get this factor here. Okay, now we start with x plus 3. Factor the denominator. 2 values to give me 1 is just 1 and 1 because it's a prime. And then it's positive, so both of these are positive. And then this one again has a greatest common factor 5. That's going to be moved to the front here. And we're left with x minus 2. Let's look at the values x cannot be again before we move on to our canceling so that we could look to see what our domain is going to be. So x here cannot equal -3, -1, and we have -1 twice, and 2. Okay, so these are the values that x cannot equal, even though we're going to simplify, these are still the values of our original equation that x cannot be, which we have to include. All right, so let's do this slashing things out business. The 5's could be slashed out. So we are left with x squared, x plus 1, where x cannot equal -3, -1, and 2, because we're finding the equivalent. Sorry about that. So here's my solution. Here is what it cannot be, x squared divided by x plus 1. So a study tip, it is easier to find the domain after factoring the denominator. Use the zero product property to find values that will make the expression undefined. In this example, x cannot equal -3, -1, or 2. All right, so here, let me just make sure that there's no odd factoring, and there is not. So there's your try-its. Ask questions if you need them, and we'll catch you in the next video.